Good.
Okay.
We'll go to section 2. Okay. There was a recent survey taken on whether consumers are labeled users who pay attention to labeled details when buying clothes. Are men and women equally likely to be label users? Determine if the portion of men who use labels are different than the portion of women who use labels with a significance level of alpha equals 0.05. Here is the data summary. Okay, check the requirements.
So, did you just put it in your Excel app?
For the requirements, will the Excel app check the requirements?
Yeah.
Oh, I didn't know that. That's cool.
That's so good. Way better than trying to work it out with that huge deal.
Okay, so the sample size, is that p hat?
So you go to the 2 proportion, right?
Yeah.
And so you just go, X1 is, let's see.
63?
63, and then 296 is the N1.
296, and then 27 and
251.
Okay.
And then there's a 95% confidence interval, and it's the one that's not equal to. You take the type of test, it's P1 not equal to P2.
Right.
So then right...
Oh, it checks requirements right there.
Yeah, right adjacent to it. There's the requirement checks.
It doesn't do that in the 1 portion test, though, does it?
I don't... Maybe it does. I don't remember it, but it does in this one.
Oh, yeah, it does. It does.
Does it?
Yeah.
So that
Okay,
checks
so...
that, and then it gives us all our information. It's kind of sweet. So,
okay,
so the requirements are good. Then we just have to write the null hypothesis as P1 equals P2, and P1 doesn't equal P2.
Okay.
And then the test statistics right there.
Yep, 3.309.
And the p-value is right there.
Yep.
And the confidence level intervals right there.
Yeah.
So I mean it's.
Or you can put in. Or you can put in your.
You could put it into your.
Normal probability applet, yeah. Okay, so what should we do? It looks like with a p-value 0.001, we would reject the null.
Yep, we reject it.
Sufficient evidence that
there's a difference.
Yeah, that there's a difference between men and women who use labels. Construct a 95% confidence interval. We got that.
So what was the difference? I'm trying to look. 63 out of 2, 96, and 27 out of 2. So women look at labels more.
Yeah.
Probably.
And then interpret the confidence interval you constructed. It says we are 95% confident that the true difference in proportions of men being labeled users and women being labeled users is between 0.045 and 0.166. That makes sense. And we have the formulas too if we wanted to really calculate it.
If we have to do it for any reason, we have the formulas. But.
Yeah, but I mean, if they're going to give us this Excel spreadsheet, why not use it? So.
I know, because those are hideously long and big.
Yeah, and there's a lot of room for error, that's for sure.
Yeah, so, I mean, I'm thrilled.
It's good. It's really good to even just check your answers if you do calculate it.
Yeah, that's a good point. And you can see if you're doing it right.
Okay, let's do the group quiz then. I think this is what we'll probably use for our study.
Oh. Okay.
Because if we count houses with lights and houses without lights, then we can put those in the population, or I mean those below the population, and then across we'll have the size, which is all the houses that we counted, and then X is the houses with lights on.
Sweet. Good.
Okay, group meeting. I like how the group quiz says that we'll be joined by a TA.
Yeah,
We
right.
never
That's
have
never
it. We've never
happened.
even been contacted. Yeah, we even have our information up too. That's the funny thing.
Yeah.
Okay.
70.
Okay, number 3. So out of 70 females in the sample, 52 can taste PTC. Out of 59 males in the sample, 42 can test PTC. Let P1 be the portion of females in the population that can taste PTC, and P2 be the portion of males in the population who can taste PTC. The research question in this study is given here. Is the portion of females who can taste PTC different from the portion of males who can taste PTC? Find P hat 1.
P hat 1, so 52 divided by 70.
Mm-hmm.
0.743.
Yep. Okay, and P2 is 42 divided by 59. 0.712. Everybody got that one?
Yep.
Okay, which set of hypotheses is appropriate for addressing the research question?
It's asking if they're different, right?
Yeah, is different from the portion of females. Yeah, so
So P1 equals
P1
P2,
equal
P8.
P2, and then, yeah, the bottom one.
What's the difference between the bottom one and the second one?
The second one's P hat.
Oh.
And we won't be studying P hat. And at least when I was reading the book, it said that the null for comparing two populations is P1 equals P2.
So it's not P hat.
Yeah, because I think it's because P hat's the sample and P1 is the true mean. So we would be studying the actual true mean, not the sample mean. But I want to check that real quick. I'm going to go open my book real quick.
Yeah, the P hat thing, I mean, the X and the U I got, but the P hat thing seems to be super confusing. No, you're right, it's P1 and P2. It's not P hat.
Okay.
That's right. So should we put this into the applet to get the confidence intervals? I mean, not the applet, but the Excel?
Sure.
Okay, so then we got X1 is 52, and N1 is 70, and X2 is 42, and 59. And then it's
not equal,
not equal.
95. Okay, I got negative 0.123 and 0.185.
Yeah.
Okay.
1, 2, 3, and 0.1.
With a 0.05, which decision do you make? Okay, so our p-value is 0.693, so you would fail to reject.
Fail to reject, yeah, because it's too
the
big.
null, not the alternative.
Right, like fail to reject the null. Yeah, that was a trick in there.
Okay, which of the following statements best describes the outcome of this study? There's insufficient evidence to suggest that the true portion of females who can taste PTC is different from the true portion of males that can taste PTC.
There is insufficient, so the second one?
I think so.
Okay, so what's the difference between the second and third? It's true proportion?
It looks like they're the same.
Less than, yeah. So we're just looking for different than less than.
Yeah, but then the bottom one, it says there is sufficient evidence to suggest that the true portion of
there's
females...
insufficient evidence, right?
Oh yeah, there's insufficient, that's right.
So it's the second.
Yeah, second. Okay. Let P1 be the proportion... Okay, out of 118,519 who had a heart attack during the week, 16,713 had died, and out of 42,447 who had a heart attack of the week, 6,155 had died. Let P1 be the portion of patients who had heart attacks and were admitted on a weekday who died, and let P2 be the portion of patients who had heart attacks and were admitted on the week and who had heart attacks and were admitted on the weekend. Oh yeah, it's the weekend.
Okay.
The research study is given here. Is the proportion of patients who have heart attacks and are admitted to the hospital on a weekday who die less than the portion of patients who had a heart attack and admitted to the hospital in the weekend who died? So it's less.
Less than, so P1 is less than P2.
That's the second one. P1
All right.
is less than, yeah.
So should we just stick it in the thing right now?
Yeah. So patients who had heart attacks were admitted on the weekday.
16713 is the X, and then 118519 is the N, and then 6155 42447. And we're at 95, and we're at less than.
8.
Okay.
I'm sorry, I'm being slow. 6155, and then 42447. Okay. Less than?
Yep.
P1 is less than?
P1's less than.
So P2 is greater. Okay. It appears, though, as everything is, all the requirements are met.
Yes.
True.
Yes, true.
The
hypothesis would be the less than one. HO, HA. Looks like it's the top one. Is that right? HA.
Yeah, the top one. Yeah.
What's the third one? HO, P1, HA, greater than. So yeah, it's the top one.
And then P hat, P1. So that is
16713
divided by
16713 divided by 188.
Yeah, 0.0141.
Wait, 0.0 or 0.1?
0.141.
And then the second one is 6155 divided by 42447.
145.
145.
145, yep. Okay. Find the z-score.
Negative 2.020.
Let me see.
Got that?
Negative 2.020. Yep.
Right.
Negative 2.02. Okay. Given the z-score from question 3, which side would you shade, the left or the right?
So we're doing less than.
So we would shade the left.
So shade the left.
What is the p-value for this test?
So since we put in half, it's the right one. We don't have to divide it. It's just 0.022.
Yeah, it should be. Yep.
And the decision is reject.
You would reject.
There's sufficient evidence to conclude that proportion of patients who have heart attacks who are admitted to the hospital on the weekday die less.
Yeah.
Yeah. That's the only one that says less.
That is the same as I say.
Yeah.
Yeah.
The third one says the same, so it's the first one.
Yeah.
Is that it?
I lost you guys for a little bit towards the beginning, so can we just go over 5 and 6?
Which ones?
5 and 6. I lost you for those ones.
Oh, okay. We just put those in our probability applet. So we got for 5 that it's the bottom one, the very bottom one. H null P1 equals P2, and then H alternative is P1 does not equal P2.
Okay. Yeah.
And then for 6, we put it in our Excel spreadsheet, and we got the second one, which is negative 0.123 and 0.185.
So for 7, you put C, right?
Yeah, fail to reject.
And then B, and then true, and then A.
True. Yep. B. True. A. Yep.
0.1411. Sometimes I just like accidentally don't hit the right thing.
Yeah, I do it too.
Okay.
Okay.
I think we're good.
Yeah. I hope we're good. 100%. Nice job.
That was not too hard of one. So you think that's the one we'll try to use then?
Yeah, I think so. I think that's what we'll use for our portion because we should count when we're taking our study, because I put it in the study that we are going to count the houses that do have lights and that don't have lights.
Okay.
Oh, so you're not saying that our two proportions will be Rexburg and South Jordan?
Well,
Lights and no lights?
they will be. So, like, if you're putting up the square, like the little square that they have, it'll be below population. It will be houses with lights, houses without lights, and then the sample size will be, that'll be Rexburg versus whatever you're saying.
The second square will be Rexburg versus
Right, and the sample size will
R and W or whatever.
Yeah, and so then the sample size will be the houses with lights and the houses without lights put together, and then X will be houses with lights.
Gotcha.
So that makes sense.
Yeah.
No. The first is population, houses with and houses without, and then the second is West Jordan or Rexburg.
Sample size and X will be all of the houses. So the sample size is all of the houses, right? And then X is the houses with lights.
Okay.
So it makes sense to count houses without lights too, because then they can go into your sample size.
Okay.
That makes sense.
Yes. So how did we decide to start? Do you want to? Should we start this week?
We can't until he approves us.
Oh, okay. So we don't have to start yet.
Yeah, we have to wait.
As far as okay, and then as far as we'll just kind of like decide what letter to start on in the phone book, and then just start looking at the.
Yeah, I put that we'll put in a random number generator. So like, you can find those on Google, but you can just pick a random number or have your kid draw a random number, or tell you a random number or something, and then you start there, and then every fifth street after.
Random number, like in the phone book?
Yeah.
Okay.
So you should get online too. There should be yellow pages to street names as well. So.
When do we have to have this like turned in, or like the data collected though? Because wouldn't we want to start collecting it a little bit later, so like, there's actually a significant number of lights up?
Yeah.
You'd be surprised.
Yeah, you'd be surprised. I mean, if you drive around Rexford even right now, there's a lot of lights up.
Yeah, it's surprising.
But I don't know. I'm not sure just yet. And with Christmas, I mean, we have Thanksgiving break coming up this next week. So, well, I hope he approves it pretty soon, and then we can talk about when we want to start collecting. But we're not allowed, in the instructions it says, you will not do anything until your instructor has given you your approval.
On the test, is it within a certain time frame? Is it before Thanksgiving? Is that what you wrote as the hypothesis?
Yes, I said before Thanksgiving. So hopefully
we need to do it before.
Right. So hopefully he approves this before. So I think
it won't be that hard. It will only take a minute.
No, it won't. You only have to drive around a little bit. So.
Yeah, it won't. We can do it within an hour easily.
Yeah.
So.
Yeah.
As long as it's before.
Since Colton and I are both in Rexburg, are we looking at the same streets, or are you looking at 5 streets and I'm looking at 5 streets?
We'll probably do different, and then we can. I didn't know what to do about that either, because
Should I just do 2 different samples, and so it's equal?
Yeah, do 2 different samples, and then we'll do 2 different samples, and then we can test them both.
Yeah, let's do that, because if you guys have more, you guys each do 1, and I'll just do 2, so we have 2 from here and 2 from there.
Or if it works out in a certain way, we can just select 1 sample size to compare. But I think that should be fine.
Okay.
If we each do 2, then we can look at it, and that would probably be a good idea.
Okay.
Because then we compare mine with Mackenzie's.
Mm-hmm.
So are we gonna? I guess as soon as you hear back from him, we'll figure out when to do it.
Yeah, I'll let you guys know.
And it might be interesting to say by this date, but I guess we don't have to change it now because.
No, and we could say we can say like Thanksgiving, but
Yeah.
we said Thanksgiving Day, so.
Okay.
Okay, sounds good, guys.
Right.
Okay, thanks.
Yep, see ya.
Yeah.